Finally, one last thing to show you, just sort of in completeness. So you remember the one-dimensional case of the second derivative of the Gaussian. So what we have here is, this was our original Gaussian. The second derivative was this inverted Mexican hat operator. And when we applied that to f, it's the same thing as taking the second derivative of the smooth version. We were looking for that spot there, and those were called zero crossings on that bottom graph. That corresponded to where the edges were, okay? But to do this in two dimensions is a little bit harder. And the reason is there's more than one direction to take our derivative. So here we have our Gaussian, the formula there, and it's this nice mountain in the middle. But we have to take a derivative in one direction. And so, that's the one, let's say, in x, and there'd be 1 in y. And then on our second derivatives, there's three choices. I can take the partial of x again, so that's the partial of f with square with respect to x squared, x twice. I can do the partial of y twice. I can also do the partial of f with respect to y. Which one am I supposed to use? Well, the correct answer is you use what's referred to as a Laplacian of Gaussian. The Laplacian operator shown here is this second derivative of f with respect to x squared plus the second derivative of f with respect to y squared. And that's what actually gives you this Mexican hat operator symmetrically. And if you apply that to the image and you take the zero crossings, you will get your edges. And in fact, if you run some demonstration code in MATLAB for edges, you can take canny edges, or you can take difference of Gaussians or Laplacian of Gaussians. They're almost identical. And you can see, and what that does is looking for the zero crossings. And it's another way of getting the edges. One of the challenges there is those tend to be closed contours all the time, whereas the canny will only find you the contours that have some magnitude support. I would tell you more people probably use canny for just doing regular edge detection.